Hi, Teacher Josie is back for another fun-full episode of learning. I promise your enjoyment. So, fasten your seatbelts and stay with me till the end of the session for you to win meaty pieces of information in graphical solutions of systems of linear inequalities into variables. Let us have this story of two grade 8 students who are both mathematics enthusiasts. Jenny is walking at Tavera East Street, Puzo Rubio, Pangasinan. She is recalling that the graph of a linear inequality in two variables is a half plane and it has infinite number of solutions. Also, she enumerated the steps in graphing a linear inequality in two variables. These are: graph the boundary line of the inequality, use a dashed line for less than or greater than, and solid line for less than or equal to and greater than or equal to. To decide which side of the boundary line to shade, test the point not on the boundary line to see whether it is a solution of the inequality. Then, shade the appropriate half plane. On the other hand, Joel is biking at Caballeros Amusement Park. While having his afternoon routine, he is thinking of system of linear inequalities in two variables. Like Jenny, Joel's favorite subject is mathematics. He is also curious of the graph of system of linear inequalities in two variables. How is system of linear inequalities in two variables solved by graphing? When we say system of linear inequalities in two variables, it is a set of two or more linear inequalities in two variables, considered simultaneously. We have here some examples. Now, an ordered pair is a solution to a system of inequalities if it satisfies all the inequalities in the system. Graphically, the coordinates of a point that lie on the graphs of all inequalities in the system is part of its solution. To solve a system of inequalities in two variables by graphing, first, draw the graph of each inequality on the same coordinate plane. Shade the appropriate half plane. Recall that if all points are included in the solution, it is a closed half plane, and the line is solid. On the other hand, if the points on the line are not part of the solution of the inequality, it is an open half plane, and the line is broken. Second, the region where shaded areas overlap is the graphical solution to the system. If the graphs do not overlap, then the system has no solution. Let's have the examples. 1. Solve the system graphically. Solution: graph the first inequality. So we will replace the inequality symbol with equal sign. So we have 2x minus y is equal to -3. Here, we will use the intercept method in graphing. So we will find the x and y intercepts. So if x is 0, our y is 3. So we have 0, 3. We plot 0, 3. We have here our y-intercept, 0, 3. Next, the x-intercept. When y is 0, our x is -3/2. So we have negative 3 over 2, 0. Plot the x-intercept, negative 3 over 2, 0. Or negative 1 and 1 half, 0. We connect the 2 points using a dashed line, since the inequality symbol here is greater than. Now, for us to know on what region to shade, we will have our test point. Let's say the point of origin. So, substitute in the inequality, 2x minus y is greater than negative 3. Then simplify. The resulting inequality is 0 is greater than negative 3. And it is true. Meaning, our test point, 0, 0, is a solution of the first inequality. So we will shade this region. This is now the graph of 2x minus y is greater than negative 3. Then, graph the second inequality. So the same procedure, replace the inequality symbol with equal sign. So we have the boundary line, x plus 4y is equal to 9. We use the intercept method in graphing. We will find the x and y intercepts. So if x is 0, our y is 9 over 4. So we have 0, 9 over 4. Plot. So we have here our y-intercept 0, 9 over 4 or 0, 2, and 1/4. Next, the x-intercept. So when y is 0, our x is 9. So we have the ordered pair 9, 0. Plot the x-intercept, which is 9, 0. Connect the 2 points using a solid line this time, since we have here the inequality symbol less than or equal to. For us to know on what region to shade, we will have the test point. Again, the origin. So substitute in the inequality, then simplify. The resulting inequality is 0 is less than or equal to 9, which is true. This means our test point is a solution of the second inequality. So we are going to shade this region. This is now the graph of x plus 4y is less than or equal to 9. Joining the graph of 2x minus y is greater than negative 3 to the graph of x plus 4y is less than or equal to 9, we now have the graph of the given system. Take note, the region where shaded regions overlap is the graph of the solution to the system. All of the points here on the double shaded region are solutions of the given system. Let's have number 2. Solve the system graphically. So solution, graph the first inequality. Replace the inequality symbol with equal sign. The boundary line is 5x plus y is equal to 3. So the same method in graphing, we will find the x and y intercepts. So when x is 0, our y is 3. So we have 0, 3. Plot the y-intercept, 0, 3. Next, the x-intercept. When y is 0, our x is 3/5. So we have 3/5, 0. Plot the x-intercept 3/5 0. Connect the 2 points using dashed line. Let's have the test point for us to know on what region to shade. Again, let's have the origin. So substitute in the inequality, then simplify. The resulting inequality is 0 is greater than 3, which is false. Meaning, instead of shading this part, this is the region that we are going to shade. This is now the graph of 5x plus y is greater than 3. Next, we graph the second inequality. The same procedure. So when x is 0, our y is negative 4. We have 0, negative 4. So plot the y-intercept. Next, when y is 0, our x is 4. So we have 4, 0. Plot the x-intercept, which is 4, 0. Connect the 2 points using solid line, since we have here greater than or equal to. And for us to know on what region to shade, let's have the test point, which is 0, 0. We substitute it in the inequality, simplify, and the resulting inequality, 0 is greater than or equal to negative 4, which is true. Meaning, our test point is one of the solutions of the second inequality. So we will shade this region. This is now the graph of y is greater than or equal to x minus 4. Joining the graph of 5x plus y is greater than 3 to the graph of y is greater than or equal to x minus 4, we have the graph of the given system. Again, the region where shaded regions overlap is the graph of the solution to the system. Take note that all of the points here on the double shaded region are solutions of the given system. Let's have this slide. Among these 5 points, only point H and point T are solutions. Let us see if you really understood the lesson. I want you to do the smile, you can do it activity. Let us check. A. Number 1, sad face. 2, happy face. And this is the graph of letter B. In response to Joel's inquiries, let's complete the following sentences. A. System of linear inequalities in two variables is a set of two or more linear inequalities in two variables considered simultaneously. An ordered pair is a solution to a system of inequalities if it satisfies all the inequalities in the system. To solve a system of inequalities in two variables by graphing, draw the graph of each inequality on the same coordinate plane. Shade the appropriate half plane. The region where shaded areas overlap is the graphical solution to the system. If the graphs do not overlap, then the system has no solution. Time really flies fast when we are enjoying. I hope you learned a lot. For more learnings, you can catch me on Vivan's Mathematics Warriors YouTube channel. See you there!